In a previous video, we looked at the compound interest formula shown here in pink, at the top on the right, and took some specific values for the interest rate, the compounding, and the initial amount of money, plugged that into the compound interest formula, and wrote this compound interest formula as an exponential function. That exponential function is what we're seeing right here in the middle of the screen. We then use that exponential function on the left and use this formula to create some data. Okay, for example, we can see here that this data point for the amount is the 100, that's the 100 right here, the 1.2155, that's the base that we found, and then to the time, A5 is the time value, that's the raised to the t power. We then went ahead and took this data from the blue formula here and asked Google to create a exponential model to fit this data with an exponential function. And then we showed that that 100 e to the 0.195t is the same formula that we generated the data with in the first place. So what we have here is a pretty consistent system that says that this data is exponential for one of a couple of reasons. First, the data came from an exponential function in blue. We didn't just make this data up, the data came from this formula. The second way we know that this data was actually exponential, let's say you didn't know the formula that this data came from. One could take this data and ask Google to do an exponential fit of it. And the fact that this function we're coming up with here actually is a formula that goes through all the data points exactly says that this data was actually an exponential function data. Okay? What we want to do now is to develop a quick test. Okay? There's a test for how do you know the test of what I'll call exponentialness. Right? How do you know that the data we're looking at is actually exponential, okay? And without going through the formulas, right, and having Google tell you that there is a function that goes exactly through all the data that looks exponential. Here is a quick test for exponentialness, and this test relies on a ratio of A values, a ratio of amounts. Here, this data we knew is probably telling us the amount of money in an account after a certain amount of time. Okay, can we see here that we've got times 0 and 1? We've got times, now this is going to be important, time 2 and time 3, and maybe time 3 and time 4. Because I have a formula underneath here, okay, we can drag this formula down and create the amount of money in the account after 4 years. So can you see that I have consecutive values in time, every data that's spaced out every year, the amount of money, see how it's growing every year. Since we have those consecutive values in time every year, we can take the ratio and create a formula that is this quantity divided by the previous quantity. So I'm going to do the ratio of the amounts in the account. Okay? Now look at this. There is the ratio of 121 divided by 100. Okay? And we have that answer. Okay? We could do this same formula equal to, let's take the ratio of this quantity divided by the previous quantity. The ratio of consecutive values. Okay. And now because we have a formula involved, we can drag and drop. Okay. Oh, sorry, this is supposed to be 3, 4, and then 5. Okay. Can you see that this ratio of A values is giving the same constant? This is a test to know that the data we're looking at, the ratio of A values, is actually that this data is exponential. The fact that these ratio of values is the same constant. Okay? So this is a test of the data is actually exponential, that there is actually a formula that an exponential function that is actually going to go through exactly all the data. Okay, so here was our data shown as a scatter chart. Okay, that's the data in blue here. How do we know that there's an exponential function going through exactly all that data? Well, we can tell that this ratio is the same of A values, and therefore, if I were to, what we know from that is that if we were to click this data, add a trend line, and ask the computer to do an exponential function through that data and show the formula, that this formula is an exponential function that goes exactly through all the data. That is because we know that this works because this ratio is a constant. Okay? And in the next video, we'll show then how to find a formula. Okay? If the ratio is a constant, we'll show how to come up with this formula using our data values rather than using Google. But here is a formula for the test of exponentialness. We're looking for this constant ratio between any two consecutive data points. So ends this video.